All right, so today we're going to be working on calculating the price elasticity of demand and working on what that means for businesses and for the government. All right, so I told you guys last time we were working through the fact that when demand is elastic, it means there are several close substitutes for a good. It's a luxury item. People have plenty of time to shop around, or it takes a big chunk of their money. Somebody did point out that one of my I made a mistake when I was talking about the elasticity of demand for elastic products last time. Is that guy here in class today? If demand is elastic, recall if demand is inelastic, any percentage change in quantity demanded will be less than the percentage change in price. For an elastic demand, the percentage change in quantity demanded is going to be greater than the percentage change in price. So if I did mess that up in your notes last time, make sure you get that fixed real quick. All right? So we're talking about how an inelastic demand is one where a product is a necessity, or there's few or no close substitutes, or you have very little time to shop around, or it takes a small percentage of your income. The one we didn't talk about was what happens, or what does it mean for demand to be unit elastic. But we're going to get to that one today. As you're going to see, there are no specific characteristics for a unit elastic demand, but the unit elastic demand is the most important one of all to businesses and to the government. Okay? Now, we saw last time when it comes to increasing your revenue, if you raise your prices, you lose sales. So you may end up losing enough sales for your overall revenue to drop. If you decide to lower your prices, you may gain sales, but you have to lower your price to do that, so your revenue may drop. So I want you to think of it this way. If you are a business, well, there was a football coach at the University of Alabama several years ago by the name of Bear Bryant. I don't know if you young people probably never heard of him, have you? Anybody ever heard of Bear Bryant? All right, a couple of you. Well, Bear Bryant was once asked why he never let his quarterback throw the football. He ran an offense that was called the wishbone, where the quarterback, when he would take the hike, he would either hand it to the fullback or fake it to the fullback, then run down the line of scrimmage, and if the defensive end came towards the quarterback, he would pitch. If the defensive end took the running back, he would turn the corner. So he had different options. But when in the 1970s, Alabama, their quarterback would throw the football maybe 3 times a game. And so a reporter asked Bear Bryant once, why do you never let your quarterback throw the football? And he said, because when you throw the football, 3 things can happen, and 2 of them ain't good. Do you guys watch football? Not soccer, that's not football, real football, okay? So you know that your quarterback can throw the football. Incompletion, that's bad. Interception, that's bad. So Bear Bryant was just playing the odds. He said, only one good thing can happen, so I'm not going to do this. Well, watch this. If you run a business, if you change your prices, 3 things can happen, and 2 of them ain't good. Right? You can change your prices and your revenue can go down. You could change your prices and your revenue stays the same. And you might say, well, then what difference does it make? It makes a lot of difference. If you have a sale, if you lower your prices, you're going to spend money advertising that sale, aren't you? So you go through all this cost of advertising, and if you lower your prices and your revenue fails to go up, you've incurred a cost without gaining revenue, so you actually lose money. Or you could raise your prices. That requires a cost of redoing price tags, okay? That involves a cost. So if you raise your prices and your revenue stays the same, that's bad too. So you could either lose revenue or your revenue stays the same. There's only one scenario. So in theory, if you change your prices, you only have a 33% chance of your revenue going up. And that's the only reason to change your prices, ever. The only reason to change your prices is try to get more revenue. So if there's only a 33% chance of it going well, that's pretty scary, especially when you could face bankruptcy if you change your prices in the middle of a recession. Okay, if your competitors do something different, they could end up taking market share. So there's got to be a way of changing that 33% equation where you've got a better chance of knowing in advance we're going to change our prices and this is actually going to work out well. And that involves being able to calculate. This is what Disney does. This is what the airlines do. They have staff of economists and industrial engineers whose job it is to calculate the price elasticity of demand, sometimes on a daily basis. The airlines have economists working for them that calculate the elasticity of demand hour by hour. That's why sometimes when you go online shopping for flights, it seems like hour by hour prices change, right? Okay, let's show you how they do it. All right, suppose that all of you in here work for a bank, and your boss comes in one day and says, listen, we're thinking about changing our fees that we charge people to use our ATM machines at our downtown Orlando locations. All right? And you raise your hand, and the boss says, okay, we're thinking about changing our fees because right now we're charging $1. We're getting 600 transactions a day, and we're thinking about raising our prices. And your boss then says, okay, what do you guys think about this? Now remember from last time, the one thing you don't want to do, if your boss says, we're thinking about raising our prices for our ATM fees, you do not, and then your boss says, well, what do you guys think about this? You don't want to raise your hand and say what? Yes, you don't want to say, but boss, if we raise our fees, won't people use our machines less? Again, if your boss is kind, he'll say, yes, but we already should have known that, right? I mean, I hired you with the understanding that your background would suggest you already know this. And if your boss isn't kind, you should be escorted out the door and replaced with somebody that actually is economically literate. Okay? So remember, every business understands the law of demand, comma. None of them care about it. None of them. All they care about is the price elasticity of demand. All right. So suppose your boss says, all right, here we are. We're going to go through an experiment similar to what our Charlotte, North Carolina offices did, let's say, and we're going to raise prices in increments of $1. Okay, so we're going to go from 1 to 2. And in Charlotte, we noticed that every time we raised prices, S3, S4, S5, S6, every time we raised prices by $1, 3, 4, 5, 6, we had 100 fewer transactions. 300, 200, and 100. We're going to call this point A, B, C, D, E, and F. Okay? Now, how many of you have had calculus? Good. If this were a calculus class, or if calculus were a prerequisite for this class, all you'd have to do is set up the natural logarithm of quantity demanded with respect to the intercept term plus the coefficients on price and the other variables. And remember in calculus you learned about taking first-order derivatives. Okay? If this were a calculus class, all you would have to do, if you knew the mathematical formula for this demand curve, okay, and in the real world of business, somebody will walk in, if you ever have a meeting over prices, with the real formula for the company's demand curve. And if you take the first derivative of quantity demanded with respect to price, and you do it in natural logarithm form because it converts everything to a percentage, you may recall, then you could calculate the precise elasticity of demand at any given point on this demand curve. In other words, you could know at a price of $1 exactly what the elasticity of demand is. But this is not a calculus class, and calculus is not a prerequisite. So we're not going to calculate, watch this, we're not going to calculate the elasticity of demand at this point, although I wanted you people who are good at math to understand this is how it's done in the real world. Instead, we're going to calculate the elasticity of demand between 2 points. In other words, our answer is going to reflect the elasticity of demand between point A and point B, between B and C, etc., even though in the real world it's calculated at any given point along the demand curve. Okay? Now, to do that, there are 3 steps that we have to undertake. All right, so calculating the elasticity of demand. Step 1, calculate the change in price. And for those of you watching online, this symbol delta, this symbol right here, means change. All right? So we calculate the change in price and the change in quantity demanded. Well, we're going to start with the change between points A and point B, so that's going to be easy. The change in price was equal to $1. We raised our prices from $1 to $2, and the change in quantity demanded was negative 100. We lost 100 customers by raising the price by $1. Okay? That's the easy part. Step 2, calculate the percentage change in price and percentage change in quantity demanded. Okay. The percentage change in price is equal to the actual change in price over 1/2 the original price, P1, plus the final price, P2. All of this multiply it by 100 to convert it into a percentage. Now, if you want to do if you're used to doing the calculations where you take the change you want to do P1 plus P2 and divide it by 2, that's fine. But look at what we're doing here. By taking the change in price, and in here, taking the original price of $1, the final price of $2, multiplying that by 1/2, down here, we're getting the average price between point A and B. So the change in price divided by the average price between the 2 points multiplied by 100 gives us the percentage change in price between these 2 points. All right, the percentage change in quantity demanded is equal to the actual change in quantity demanded divided by 1/2 the original quantity demanded plus the final quantity demanded, all of this multiplied by 100. All right, let's work through that. All right, so let's start with the percentage change in price. Percentage change in price, and we'll do every step the first time, okay, just to make sure you guys have gotten it. And when we break you up into your groups in just a moment and have you work on it, I want you to make sure everybody understands each step, okay? So percentage change in price is the actual change in price, so that's $1 over 1/2 the original price, which is $1, plus the final price at point B, which is $2. We're not jumping all the way to 6 yet, okay? All of that multiplied by 100. That's equal to 1 over 1/2 of 3 times 100, which is equal to 1 over $1.50 times 100, which is equal to 0.6667 times 100, which is equal to 66.67%. Okay? Now look, some of you want to look up here and go, wait a second. An increase from $1 to $2 is an increase of 100%. Others might say, wait a minute, no, it's just 50% because 1 is 50% of 2. Think of it this way, and this is why I even mentioned calculus. Think of it this way. Think of the bank actually raising its fees from 1 to 101, 102, 103. We're trying to capture the average percentage change in price between these 2 points. So by doing it this way, it captures incrementally every possible price change, not just a jump from A to B. Does it help you a little bit? In essence, that's what this formula does. It captures the average percentage change in price across the entire range from point A to point B. Okay? So, all right, notice, we raised our prices by 66.67%. Now, let's capture the percentage change in quantity demanded. All right, that is equal to the actual change, which is you lost 100 customers, divided by 1/2 the original quantity demanded, which is 600, plus the final quantity demanded, which was 500 at point B. All of that multiplied by 100 to convert it to a percentage. So that's equal to negative 100 over 1/2 of 1100 times 100, which is equal to negative 100 over 550 times 100, which is equal to negative 0.1818 times 100, which is equal to negative 18.18%. Okay. So you increased your price by 66%. Quantity demanded went down by just over 18%. Now, in going back to what you folks online have read, or you guys live heard last time, if you raise your price by that amount and quantity demanded changes by this amount, it would seem that the elasticity of demand for ATM services in downtown Orlando for this particular bank, the elasticity of demand is what? We've only talked specifically about two. It's either inelastic or it's elastic. And remember, for purposes of the preparation for final exam, the best way to keep the two straight is to always revert back to those four characteristics. Inelastic, somewhat of a necessity, not many substitutes, doesn't take a big percentage of our income, not a lot of time to shop around, okay? Elastic, luxury item, a lot of substitutes, a long time to shop around, a big chunk of your earnings. If you raise your fees by 66% on your customers and you only lose 18%, that's an indication that the elasticity of demand is what? Inelastic. Remember, the very first part of an inelastic demand is the customers are not very responsive. Well, that's not very responsive, is it? Well, let's see if the final part of the calculation verifies whether we're right or wrong. All right. Step 3. The elasticity of demand equals the percentage change in quantity demanded divided by the percentage change in price. So that's equal to negative 18.18 divided by 66.67, which is equal to what? Negative 0.27. Now, some of you have read in the book a quote by a guy at North Carolina State University who was actually my econometrics professor when I was doing my PhD work there. This guy's name was Dr. David Dickey, and he was the scariest human being because he taught the scariest class at this college. Every major has a class where if you don't survive this one, you're not going to ever have a job in this field, okay? And the PhD econometrics class at North Carolina State, this was it. And there were about 8 of us in the class, and he walks in the first day, and we're scared to death, as if Frankenstein's about to walk in, even though he was a nice-looking guy. The Frankenstein part was the class. We all knew what was coming here. And he said, and by the way, this guy was what you call scary smart. In the 80s, he actually had a mathematical formula named after him. If by the 1980s you're discovering new mathematical formulas, you're having dinner with Einstein and people like that in the afterlife, okay? Now, he comes in the very first day of class and he says, remember, and we're all leaning forward like one of those E.F. Hutton commercials. He says, never ever calculate a number whose meaning you do not understand. And all of a sudden, I'm back in my 9th grade algebra class where I had to cheat to make F's in algebra the first time I took it, okay? I would have made F minuses if I hadn't cheated off everybody I could. My algebra teacher, who I can't mention because we're videoing today, all right, he would stand at the board with his hands down the back of his pants, never looked at us, and he would work problems on the board, and he would have us do this stuff. And then he'd walk around the room to check our work. And on the rare occasions that I would get something right, watch this, he would go by and say, well, that answer's right. And I would say, because I'm a visual learner, I would say, what does this answer mean? And he would say every time, or the few times he's talking to me, don't worry about what it means. It's the right answer. I didn't learn anything. I loved calculus, because I could visualize the rate at which somebody was climbing a mountain or a profit or cost function, and the numbers, the answers had meanings, okay? So when you look at this, what does negative 0.27 mean? Well, it means a lot, and we'll see what that means right now, all right? Well, first of all, to understand what negative 0.27 means, we have to establish some rules for understanding different elasticities. All right. First of all, if the elasticity of demand is less than 1, demand is inelastic. The elasticity of demand is greater than 1, demand is elastic. And number 3, if the elasticity of demand equals 1, demand is unit elastic. Okay? So, negative 0.27 is inelastic. But watch this for just a second. Just real quick. What if you run a store? What if you run a store and someday you lower your prices by 10% and quantity demanded goes up by 40%? Okay, watch this. Change in quantity demand, elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price. You lowered your prices, that's a negative, right? You lowered them by 10%, so that equals a negative 4. Right? Now look, negative 4 would suggest, since it's less than 1, that when you changed your prices, you got an inelastic response, correct? But look at it. You changed your prices by 10%, and they bought 40% more. Does that look like it's inelastic to you? No, that was a huge response. But it came out negative. It came out less than 1. Now, those of you watching online, I'm going to stare at my live students till somebody indicates whether or not they read the book before they came to class. But you won't video their faces as we go. No, it's just all on me. So there you go. So we can just stare at each other, and you know nobody will ever see you on YouTube. Okay? What? Thank you very much. He just suggested that we take the absolute value of our answer. Now, in your math classes, you may recall, you take the absolute value of a number when the symbol in front of the number, negative or positive, means nothing with respect to what the number means. Remember that? And that's the case here. Look, the answer is always going to be negative because of the law of demand. When you raise your price, you sell less. Positive over negative is negative. When you lower your price, you sell more. Negative over positive, negative. So the answer is always negative. All the negative sign means is we're verifying the law of demand. But the negative symbol doesn't mean anything with respect to the number. So over here, we would have taken the absolute value, so it's equal to 4. 4 is greater than 1. Aha, elastic. Yeah, you doggone right, elastic. I mean, you lowered your price by 10%, you bought 40% more. Here, you take the absolute value, it equals 0.27, still less than 1, but it lines up with what we discovered, not a very big change in their behavior, so we're fine. Now watch this. 0.27 not only means that in this range from A to B, the customers responded in an inelastic manner. It also means mathematically, from point A to B, every 1% change in price equals a 0.27% change in quantity demanded. Listen, it means whether they would have raised prices along this range or lowered prices along this range. Every 1% change in price yielded a 0.27% change in quantity demanded. Okay? Now, for those of you watching at home, at this point, what you need to do is hit pause, and you need to calculate on your own the elasticities of demand between point B and C, C and D, D and E, E and F. This will give you the practice that you need to prepare for the final exam, where you're going to have to do these calculations as well. And for those of you sitting in on this live, we're going to stop the video right now. I'm going to break you up in groups, and I'm going to assign you which one I want you to do, and we'll see what the answers do over time. Okay? All right, let's do it. Okay, so for those of you who did the calculations at home, if you did what you were supposed to do, you found out that the elasticity of demand between point B and C is 0.55, between C and D, 1.00, D to E, 1.80, and E to F, 3 0.67. Now, let's do the math first, the mathematical explanation for these numbers, and then we'll do the economics explanation. Because when you think about it, it would seem, listen guys, it would seem that on a constant slope demand curve, if it's constant slope, remember slope is rise over run, if every time they raise their price by $1, they lose 100 customers, if the slope stays the same throughout the entire function, it would make sense that the elasticity of demand would stay the same. So let's explain the math first on why it doesn't stay the same, and then we'll get to the economics, because you can see the economics is very important because all three elasticities show up. And this gets back to Bear Bryant. You better know which one you're about to do because two of them can blow up in your face. Okay? All right, first the math. This is simple. When we're dealing with slope, you're dealing with the numerical change in price and quantity demanded. Raise price by $1, lose 100 customers. But elasticity is not based on the numerical change, it's based on the percentage change. Watch, look up here. When you're charging $1 and you raise your price from 1 to 2, remember, that was a 66% increase in your price. By the time you get up here to $5 and you raise it by $1 more, it was only an 18% increase in price. So it's the same $1. But down here, going from 1 to 2 is a huge percentage change. Going from 5 to 6 is a small percentage change. When you had 600 customers and you lost 100, in percentage terms, that was pretty small. But by the time you're down to 200, if you lose 100 customers, that's huge in percentage terms. So since elasticities are based on percentages, it makes sense that the elasticity of demand is going to change over the demand curve because the percentages change over the demand curve. We're good? Any problems? All right. Now to the economics. Does it make sense that for a while demand is inelastic and eventually it becomes elastic, even very elastic? Now, when I ask the question, does it make sense, you immediately go back to your book or the notes and you look up what? The characteristics of an inelastic and elastic product. Let's think about it for a second. So, for a while, when the bank raised its ATM fees, first it got a very inelastic response, still somewhat inelastic, but not as inelastic. Does it make sense at first? That's how bank customers, just envision people out, on their lunch hour or Saturday night or whatever the case might be. Does it make sense that at first demand would be inelastic for a major bank's ATM fees? Why? Well, one would be raising it from 1 to 2 or 3. It's still a relatively small percentage of our income. That's an inelastic characteristic. What else? You may not have, on the weekends or you're an office worker and you're going out for lunch, you kind of get familiar where the bank's ATM machines might be. So you might not have a lot of time when you walk up and go, wow, they've raised to 2, raised to 3. You may not have a lot of time initially to shop around, and you may not be willing to shop around because it's just a couple of bucks. What else may be a reason? Did you have one? Go ahead. Always. And on the final exam, anytime I present an elasticity to you, I'll never have the negative symbol in front of it. I will have already removed it because that's all we need to know. All right, so you don't have a lot of time to shop around. It doesn't take a big percentage of your income. What else? Yeah, it may be still somewhat of a necessity. Maybe, it's your bank. You're somewhat brand name loyal to it. You're not going to go shopping around for another bank. So for an extra buck, you're not going to worry about it. Okay, anything else? There may not be a lot of substitutes available, especially if you have a time crunch. By the time you're charging $5 or $6 for people to pull their money out of the bank, it's a bigger percentage of people's income. When word eventually gets out, hey, they charge $6 for you to do a $20 transaction, People are going to search for and find substitutes, and the substitute could be, going to the one in the suburbs, fixing their lunch before they go downtown, making sure they got plenty of cash on hand when they go to Publix. They'll just go ahead and get cash back. Oh, I'm not going to go to the downtown. So they'll find substitutes. It takes a bigger chunk of their income. It's now a luxury. They don't have to go to that ATM machine, okay? And they're going to take a lot more time to shop around for a better deal and maybe even a better bank. Okay? So it makes some sense intuitively that these characteristics are going to be different, and it makes some sense, therefore, the elasticities are going to change. Now, let's take this for just a moment and show you something about the real world that all of you need to know. Okay. First of all, here we go. Let's talk about Disney for just a moment. Now, we're going to see in just a moment that every demand curve, what we're going to see on this demand curve, not only is there a range where it's equal to 1, there's a point where it equals to 1. So we're heading to this one in just a moment. This is the punchline. This is the holy grail for businesses, so to speak, that all of them look for. So we're going to see in just a moment that on any given demand curve, there's a point where demand is unit elastic. In the lower range of the demand curve, demand is inelastic. The upper range of the demand curve, demand is elastic. Okay? This is just the way it is. Now, when it comes to Disney and what they charge for theme ticket prices, all right? Elasticity demand equals 1. What do you notice that Disney does virtually, if not every year, when it comes to the theme park ticket prices? Raises them. Okay? Now, if you're raising your prices every year, you must have some evidence that the demand for your product is... Remember, the answer is not high, low, neutral, increasing, decreasing. Nope, 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 nope. What words have we been using now for 2 straight days? Elastic or inelastic. Stick with the vernacular we're using right now. If you're raising your prices, you probably believe, or you have evidence to believe, that your demand is inelastic. Very good. Go back to the characteristics. When Disney raises prices, it's as if they say to tourists coming down here in the summer, what are you going to do? Skip us? You can go to Gatorland and the Kennedy Space Center and the beach? And listen, you drive down here from Minnesota with a van filled with kids. You stop at the gate, and first of all, it says $14 for parking. That's what gives me a stroke. I'll park and walk through the woods if I have to. All right? But you stop, and if you were to ask somebody at the gate about parking, excuse me, how much is a ticket? And they say, what is it now, 70 some odd dollars, right? And they say $75, and you tell your kids, listen, there's 6 of us here, we really can't. They will tie you to the steering wheel with duct tape, set you and the van on fire while they're running towards the gate with your wallet. If you're on vacation, Disney is a necessity. That's it. Now, Universal Studios is becoming much more of a close substitute. There are people now, because of the Harry Potter thing, going forward, and Disney's going to have to react to this, okay? Because Universal Studios is now trying to give people the mindset, hey, you could, especially if it's your second or third visit, you could come just to Universal. You don't have to go to Disney again. And there might even be some people on first visit, if they've got teenage kids, okay, where they say, hey, let's just skip Disney and just go to Universal Studios. But for now, still, very few good substitutes. It's a necessity. The amount of time you have to shop around and wait for Disney to give you a deal, you're down here for a week, 2 weeks tops. So you've got no time. The people who live here, of course, have all year to wait for them to give us a Florida resident discount. And you might say, okay, what about the percentage of your income? The tickets compared to what you've already paid for flights, gasoline, hotels, okay? The tickets are going to be a relatively small portion of the total income you're spending on this vacation. So right now, we can be certain that if supply and demand intersect somewhere, let's say it's $80, whatever, and this is Q1, right now supply and demand intersect somewhere along Disney's inelastic portion of their demand curve. Now what this means is that Disney probably has a way to go. Let's ask this question. Let's draw a supply curve right here, okay? Watch this, and we'll put a blank and a price, but we do know that right here is what portion of the demand curve? You've just entered the elastic range of the demand curve, okay? Where all of a sudden your product becomes a luxury. There's plenty of substitutes. Takes too much of people's income. They're willing to shop around, okay? Wait for deals, whatever. Now, Disney has this point. Listen to me carefully. Remember when we talked about the law of demand? We said that there has never been, nor will there ever be, a good or service on the face of the earth where the law of demand doesn't apply. You raise prices, somebody somewhere is going to buy less. Here's another law as it applies to the every demand curve has all three characteristics. Every demand curve on any given day has an inelastic range, a point where it's unit elastic, and an elastic range. Disney could charge a price next year where demand is elastic, people view it as a luxury, we don't have to go, we'll go to the other substitutes, it takes too much of income, we'll come back some other time when they get a better deal. Now, the question is, what is that price? Disney knows what it is. Again, they have economists, mainly industrial engineers do this. And by the way, they make a lot of money. For those of you really good in math, if you really like economics and you're really good in math, consider majoring in industrial engineering. These are the guys that are the mathematical economists that work for corporations, putting together cost functions, production functions, telling them how to work, telling them the right mix of capital and labor, and the elasticity. These are the cats that make all the money, okay? So Disney's industrial engineers know they could go today and say, if you were to charge this price, we would be in some trouble. But here's the thing. Disney also is far away from that price right now. Is it 100? Is it 125? I don't know what it is. But what we do know is that every year, Disney kind of marches up their demand curve. Now what they hope, watch this. Let's do some real-world analysis for a second. Look at this. Demand. Let's say Disney's here right now at around $80, okay? Now, looking up at this, you might say, wait a minute. If they keep marching up the demand curve each year with price hikes, eventually they get to the point where they're going to be in some trouble. Here's what Disney's counting on, okay? The fact that we don't have a snapshot, demand curves don't remain static. The real world is not static, meaning unchanging. The real world is dynamic. So Disney is counting on our current economic recovery to speed up, continued economic growth in Brazil, where they got a lot of customers, growth in China, Eastern Europe, wherever. What Disney's hoping for, look, is that over time, you see, over time the demand curve will shift to the right, which means a new point where the elasticity of demand equals 1, okay? So if they're charging $80, look at this. See what's going on here? If they're charging $80 now, look at where it is on this demand curve, but look where it is on this one. Now they've got a lot longer to go. Here, they might only be able to get away with $127 in 2011. But if the economy continues to grow and the world becomes richer, if demand goes up, now $80 is nowhere near this, and the new price where they're about to be in trouble might be $150, okay? This is how the real world works. Demand curves shift out and in. These things can, as a matter of fact, right now, I mean, if we were to go back into a severe recession and maybe even a global depression, whatever, the demand for Disney tickets would drop, and that $80 might already be too much, and Disney would have to back off, start lowering prices. So just what I'm getting at is this. Someday in the real world, understand two things. Number one, keep those characteristics straight in your mind so that when you're working for a company and they start talking about raising or lowering prices, you immediately never think about the law of demand, never think about up and down. It's always elastic, inelastic. Now, a lot of businesses can't afford to do what Disney and the airlines do. Small businesses don't have economists or industrial engineers doing these calculations. They have to rely on something which gets me in a lot of trouble when I talk to sociologists, but I'm going to go ahead and say it. They have to rely on common sense. Some sociologists I've talked to said there's no empirical evidence that human beings have common sense. Wolves do, wolverines do. Now, I'm driving on the roads, I would agree that sociologists may be right under certain circumstances that people have no common sense. But watch this. What I mean by this is, if you run a business someday and you never have enough money to hire economists to do these calculations for you, just pay attention to your business and what you sell, when you're selling it, and who you're selling it to. If you're a dry cleaning establishment and you open up a new business in Pine Hills, okay, first thing, maybe you notice there's 5 other dry cleaners in the area. That tells you there's a lot of substitutes for a product that's very similar, right? I mean, what dramatically different service can you offer if you're dry cleaning? So let's say you've got 5 competitors. You open up in an area of relatively modest income. So that tells you dry cleaning is going to take a big percentage of their income. So you got a lot of competition, takes a big percentage of income. Poor people take more time to shop around often. So just common sense would tell you, I probably am going to be selling a fairly elastic service. I need to think about keeping my prices low or having frequent coupons or 2-for-1 specials, things like this. Okay? And if you're a business, well, there's this bakery up in Atlanta that I used to go to all the time. There's this bread called challah. It's this sweet egg bread that Jewish people eat a lot of. And there's this one little bakery in Atlanta that I used to go to. And every time I would go there, the line would be out the door forever. And every time I would finally get in, you would hear people saying to the owners, "You have the best challah in the city." And I drove, Look, if you're seeing long lines and people saying, "This is the greatest thing in the world, and I've driven 4 hours to get here, and I would never go anywhere else," you don't need some economist to say, you don't even need to know the term elasticity of demand. All you need to know is they're telling me there's no substitutes, they're not shopping around, they're willing to pay, and you just keep raising your prices while you can. Do you understand? By the way, there's some good news here. There's some good news. This applies to oil too. The next time one of your friends says to you, "The oil companies can do whatever they want. They charge $9 a gallon. OPEC can do whatever they want." No. There is a price where we will get on a bicycle or on a bus. Prediction, okay? And maybe I'll keep this on my website and long after I'm dead. And I told my wife the other night, in the year 2100, people will go to museums in America and they will look at cars that we drove now, and people in the museum will tell them what cars ran on, and little kids in the year 2100 will say to their moms and dads, "We used to go from point A to B burning dead dinosaurs." Are you kidding me? Watch this. Drop this on somebody at a cocktail party. How many of you have ever heard the phrase, "Someday we're going to run out of oil"? Raise your hand if you've ever heard that. How many of you, if you had $1 for every time you've heard that, how many dollars would you have? Thousands, right? Thousands of dollars. Now watch this. Here it is. It is economically impossible to run out of oil. This planet will never run out of oil, ever. See, the people who say we're going to run out, here's what they picture. They picture something that is happening, okay? The growing population and world economic growth, we're burning dead dinosaurs at a faster rate than new oil reserves are being found, okay? So demand is growing faster than our capacity to supply. I mean, when your kitty cat dies someday, it will become oil about 1 million years from now, okay? It'll be a little pint of oil where your cat died and got covered up with dirt, okay? Now, but the problem is, in India, China, and everywhere else, we're burning this stuff faster than your house plants and your kitty cats can become new oil. But it doesn't matter. See, the people who say we're going to run out someday, they always miss one key variable they never talk about, and that is this: price. Oil has a price. And as long as demand keeps growing for this thing that is a necessity now, as long as demand keeps growing faster than supplies, new supplies get found, someday what will happen to price? It will go up to a level where other substitutes will be more economically viable, not politically viable. And this is my problem with Albert Gore. This is my problem with President Obama. Watch this. If the president really cared about energy policy, he would come out and announce to the American people, my energy policy to the United States of America from now on will be to tell you this: be patient. That's it. Just be patient. Just wait. Because see, the higher the price goes, the more the alternatives to oil businesses want to invest in. Westinghouse, GE, other companies that sell energy-related products. If oil goes to it's $107 a barrel today. It was $147 in 2008. If it goes back to $150, $175, $200, if we're paying $6.38 a gallon someday, that creates the proper incentives for alternative energies for businesses to invest in their research, development, and eventual demonstration. And if they demonstrate that they're economically viable, see, the problem with Albert Gore and President Obama and all the people who say we should care about, look, watch this. I love this. You ask an environmentalist, you can trick them easy because I've done it before. And they get mad and they leave, but that's okay. Who wants to talk to them anyway? All right, watch this. When gas prices go up dramatically, you'll get some of the more liberal types complaining about rising gas prices and oil company profits, okay? But I always say to them, why are you mad? I'd like to ask you a question to show you shouldn't be mad. Do you care about global warming? And the same people, watch this, the same people out of this side of their mouth that are complaining about Exxon's profits from $4 gasoline, out of this side of their mouth will say, yes, I want us to fight global warming. And then I'll say to them, well, then you should hope for $9 a gallon. You see, you've got to pick. If you can't be mad at Exxon. See, if you're a global warming person, you want Exxon to make trillions in profits from $30 a gallon in gasoline. Because the higher the price of gas, the more it reduces our consumption and saves the planet, if we're the ones ruining the planet. If you're an environmentalist, the last thing you want is $1.50 for gasoline, okay? So you either care about global warming or you care about the price of gas. You can't say you care about both. I think it's too much and I care about, and you can't do that. See, I want gas to be a nickel because I don't own polar bears. I'm not concerned about them right now. I think they've got plenty of ice. Plus, if I went up there around, they'd try to eat me. So why would I care about something that wants to eat me, okay? So I'm more concerned about, if gas prices, and you better admit it too, and those of you watching on, you know it's true. If gas prices fell to a nickel tomorrow and stayed that way for 5 years, you'd be so happy that anybody bringing up climate change to you, you'd just say, I don't want to talk about it. So let's not lie. Okay? So if you really care about climate change and you really think we're doing it, what you want is for gasoline someday to be priced where demand is elastic. How far are we from that? I'm going to admit a mistake I made years ago. Watch this. 10, 12 years ago, when I was talking to my students about gasoline, I told them that I thought $2.50 a gallon. I told them, I said, I think if it ever gets to $2.50, we will hit the point where anything above that, you'll see dramatic changes in people's behavior. But back then, gasoline was 90 cents a gallon. And the thought of even $2 a gallon would freak you out, okay? But I was absolutely wrong. We got to $2.50, $3, $3.50, $4. We hit $4.11 a gallon in August of 2008. And all people did was complain, but they still filled up. So is it $5? Is it $7? Is it $10? I don't know what it is, but it is there someday. We're nowhere near it, getting closer, but we're nowhere near it. But if we ever get there, That price, watch this, will eventually get to a price of gasoline where the last 1,000,000 barrels of oil under the ground will stay there forever because it won't be economically viable to pull it out of the ground. And electric cars or hydrogen cars, something else will have passed it by as a cheaper substitute. And we won't use gas anymore. And that'll give us the little dinosaur museum and all that stuff. Okay? All right, next thing in your notes. How businesses use the elasticity of demand to maximize total revenue. All right. How businesses use the elasticity of demand to maximize total revenue. All right. Not necessary to draw this unless you're kind of a visual person, and this will help. We have price and quantity. Here we're going to have total revenue and quantity. We're going to have our demand curve, and we're going to start out with S1 at a price of $1 and consumption of 600. Okay? And over here we're going to have price, quantity, total revenue, and the elasticity of demand. Okay. Back to our banking example. When they were charging $1, they had 600 transactions. Remember, total revenue is price times quantity. So they had $600 in total revenue. They raised prices to 2. Transactions fell to 500. Law of demand. Nobody cares about the law of demand. 2 times 500, their revenue went up to $1,000. Now, notice in here that between 1 and 2, the elasticity of demand was 0.27. We're going to fill in all the numbers and the graphs, and then we'll summarize. At $3, they lost another 100 customers, but it's okay because your goal is to get more money. That's it. Revenue went to $1,200. That's great. And the elasticity of demand was 0.55. They went from 3 to 4. They dropped down to 300 customers. Revenue stayed the same, 1,200. And the elasticity of demand was equal to 1. They went from 4 to 5. Consumption dropped to 200. The revenue dropped. The elasticity of demand was 1.8. And finally, they got to $6. Quantity demand had dropped to 100. Now the revenue is back down to $600. And the elasticity of demand was 3.67. Okay. Watch. These two graphs are in your book, so it's not necessary you try to reproduce them unless reproducing helps it gel in your mind. So some of you just sit tight and watch. When they charged $1 and had 600 transactions, we come on down, 600 transactions yielded a total revenue of $600. Okay? Now, watch this right here. There was another place where they earned $600, okay? So you earn $600 here and you earn $600 here. They earned $600 when they had 100 transactions. If you go straight up to the demand curve, that's when they were here charging $6, 100 transactions. Now, they raised their price. Here we go, S2. They raised their prices to 2. They dropped to 500 transactions, so if we come on down, because we have Q here and here, 500 transactions yielded a total revenue of $1,000. There was another place, look, right here they earned $1,000. When they had 200 transactions at this supply curve where they charged $5. Again, S3, they raised their prices to $3. Now, they earned $1,200 on 400 transactions. They also earned $1,200 right here when they had 300 transactions, 300, and this intersection of supply and demand where they charged $4. Now look, watch. Through here, they raised their prices. This is the inelastic range of the demand curve, right? And notice their revenue increased. Number one, rule number one, to increase revenue, raise your prices if and only if demand is inelastic. And keep raising your prices as long as demand is inelastic. Now, there are multiple ways to raise prices. You can just announce a price hike. Some businesses will reduce their length of hours, but Disney raises prices in the wintertime without you knowing it. Because they charge similar ticket prices, or maybe slightly less, but they reduce their number of hours, so they get more per hour. Some restaurants make their portions smaller, charge the same price. That's raising the price per ounce. Grocery stores have recently been making, you get less cereal, a few less cookies, whatever. People don't, I always, when I go grocery shopping, I don't look at the price, I look at the price per ounce. That's where you do your comparison shopping. Okay? And grocery stores have been doing it. It's called weight out, getting some of the weight out, same price. That's a way of very cleverly, because if you just openly raise prices, people think you're ripping them off. So there are many ways to raise your prices without it being so obvious that you're raising your prices. But as long as demand is inelastic, if you want more revenue, raise your price and keep raising your prices as long as demand is inelastic. And you can see it here. Look, demand was inelastic, revenue went up again. And you can see it graphically here. As long as you march up the inelastic range of the demand curve, revenue went up. Now, look up here. If you were at $6 or $5, what should you be doing? Lowering prices. Look, down here, if you're at $6, you're only making $600 in revenue. If you lower your prices to $5, lower them to $4, your revenue goes up. And we can see it as long as you go down this range. This is the elastic range of the demand curve. Your revenue climbs, doesn't it? As you're moving this way, your revenue goes up. Rule number 2. If demand is elastic, to earn more revenue, lower your prices and keep lowering your prices as long as demand is elastic. Now, some of you, I know for some of you, it's the combining of these graphs you're trying to work, but do you have any questions thus far? Because you're hearing it, you auditory learners, but you're seeing it too. So the visual learner should be fine. The auditory learner should be fine too, because you're hearing it, rule 1, rule 2. I just want to make sure, does this make sense to you so far, what your behavior should look like? Now, we're getting there. Now watch this. If you keep raising your prices into the elastic range, what happens to your revenue? You cross over, and now you're raising prices here. Your revenue is going to start to drop. Never raise your prices when demand is elastic. Because remember, it means there's a lot of substitutes. They're going to shop around. Now it takes a big chunk of their income. So you're going to be hurt now if you do this. By the same token, look at this. If you're lowering your prices, if you keep lowering them, you enter what range of the demand curve? The inelastic, and your revenue starts to drop. Guys, the airline industry used to do this. McDonald's and Burger King used to do this. They used to get involved in what are called price wars. A price war is a series of continual price cuts designed to hurt your rival. But look at what this does. The airlines used to do a lot of this, not as much anymore. Somebody would lower their prices from $300 to $250. And at first, because the demand for airline tickets is elastic, people shop around for the best price they can get, and they typically aren't very brand name loyal. When they lower the prices, at first they steal away a lot of customers from the rival airlines because demand is elastic and they get more revenue. But then the other airlines join in, and one says, okay, you cut it to $250, I'll cut it to $220, then $199. And what used to happen is the airlines, at first they would cut rates and get a lot more people to fly, steal customers from one another, and they would make more revenue, but the price war would take them into this range where they would lower prices another 40%, but the planes were almost full. They'd only sell 3 or 4% more tickets. So now you're lowering prices by 40%, you're only getting back 3% in quantity demanded, so you now start to lose revenue. And you might say, why don't they just call the price war off? You know how you call off a price war? you'd be the first one to raise prices. Once you get involved in this, it's hard to call it off. Burger King and McDonald's used to do this all the time with their value. They sold the same thing, and they just keep cutting prices. They've called it off. Burger King has now acknowledged, okay, we're going to do mostly burgers. And McDonald's, look at how McDonald's has adapted to the marketplace and has changed. I mean, you wouldn't recognize McDonald's if it traveled from 20 years ago to today. McDonald's has so many more other healthier product offerings. Instead of getting involved in these costly price wars, they've basically called it off by McDonald's moving in one direction with their menu, Burger King moving in another direction, so they don't have to directly do these price wars anymore. So never lower your prices when demand is inelastic. You saw that Valencia is going to raise tuition by 8% this fall. It's in the newspaper. UCF by 15%. For people complaining to Valencia, don't complain. I mean, what are they supposed to do? Give you a discount when it's a necessity? When you're not going to go somewhere else? As a matter of fact, I think UCF, here's what universities ought to consider. Raising prices by, say, 15% for juniors, 30% for seniors, 50% for seniors in their last semester. Who has the most inelastic demand over at UCF? Those in their last semester. See? So this would make more sense in terms of the elasticity of demand. In terms of cruelty and human misery, well, economists don't even understand those terms, so we don't care. But in terms of revenue, it would make sense to do this.
Affecting reputation does affect revenue.
Yeah, you could get away with it briefly, okay?
Very briefly.
Yeah, maybe very briefly. But look at it this way. I mean, UCF now is what? In total enrollment, one of the top 3 or 4 universities in America? So even if they drop to 47,000 or 40,000, if you raise your price and don't lose an offsetting change in the percentage quantity demanded, you can still be fine. UCF, in other words, UCF doesn't need to worry about enrollment growth. They need to worry about revenue. But the state wouldn't let them do this anyway, so it doesn't matter. All right, the punchline. Well, remember, right in here, the elasticity of demand was equal to 1. Okay? And look, right in here, whether you charge $3 or $4, your revenue was the same. So you might say, you might reach the conclusion that charging either 3 or 4 is fine. Either one, you maximize revenue. No. This is a hill. There's only one peak on any given hill. You guys remember your calculus stuff. There's only one maximum on any function that has a global maximum. So look, this point is not maximum revenue. This point is not maximum. This point is right here. Right in the middle at a price of $3.50 and a quantity of 350. And if you do the math, you end up seeing that this is revenue of $1,225. So a price of $350, quantity 350 is $1,225. Now listen, look at what you've got here. If the elasticity of demand is equal to 1 between these 2 points, mathematically, that means that exactly at the midpoint, it's equal to 1. Because to get an average of 1, that means that here it's 0.99, 0.98, 0.97. Here it's 101, 102, 103, right? So right in the middle, it's exactly equal to 1. And for those of you who did the calculations, you saw where it was 1, you raised your prices by 28.57%. And your quantity demanded went down by 28.57%. So if you end up charging a price that corresponds to a demand that is unit elastic, elasticity of demand equals 1, you have reached the point of maximum revenue. And if you're on the maximum point, think about standing on top of it. You climb a mountain and you're standing on the top of the mountain. If you step up in any direction, you can't gain anything else, can you? If you step out in any direction, which way are you going? Down. If you've reached the peak of revenue, if you lower your prices, you immediately enter the inelastic range, meaning your revenue is going to do what? If you're at 1, if you lower your prices, now you enter the range where it's 0.99. So you enter the inelastic range where you're going to lose revenue. See? If you lower your prices from here, your revenue starts to drop. Once you're here, if you raise prices, your revenue is going to drop. So back to Bear Bryant. When you change your prices, 3 things can happen, and 2 of them ain't good. When you change your prices, 3 things can happen, but you can almost guarantee the one good thing to happen. If you know your current elasticity of demand, or have a pretty good idea, and you know where unit elasticity is on your demand function, then you can either have sales until you get there, raise prices till you get there, and once you get there, stop because you have maximized revenue. All right? So the next thing that you're going to be focusing on in your book is how the government uses all this to impose special taxes on us. And we'll move on to the productivity and cost chapter after that. All right, we'll see you next time.